Suppose you have an equilibrium established between four substances A, B, C, and D. A statement of Le Chatelier's principle. If a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium moves to counteract the change. Using Le Chatelier's principle with the change of concentration. What would happen if you change the conditions by increasing the concentration of A? According to Le Chatelier, the position of equilibrium will move in such a way as to counteract the change. That means that the position of equilibrium will move so that the concentration of A decreases again by reacting it with B and turning it into C plus D. The position of equilibrium moves to the right. This is a useful way of converting the maximum possible amount of B into C and D. You might use it if, for example, B was a relative expensive material, whereas A was cheap and plentiful. What would happen if you change the conditions by decreasing the concentration of A? According to Le Chatelier, the position of equilibrium will move so that the concentration of A increases again. That means that more C and D will react to replace the A that has been removed. The position of equilibrium moves to the left. This is essentially what happens if you remove one of the products of the reaction as soon as it is formed. If, for example, you remove C as soon as it was formed, the position of equilibrium would move to the right to replace it. If you kept on removing it, the equilibrium position would keep on moving rightwards, turning this into a one-way reaction. Using Le Chatelier's principle with a change of pressure. What would happen if you change the conditions by increasing the pressure? According to Le Chatelier, the position of equilibrium will move in such a way as to counteract the change. That means that the position of equilibrium will move so that the pressure is reduced again. Pressure is caused by gas molecules hitting the sides of their container. The more molecules you have in the container, the higher the pressure will be. The system can reduce the pressure by reacting in such a way as to produce fewer molecules. In this case, there are 3 molecules on the left-hand side of the equation, but only 2 on the right. By forming more C and D, the system causes the pressure to reduce. Increasing the pressure on a gas reaction shifts the position of equilibrium towards the side with fewer molecules. What would happen if you change the conditions by decreasing the pressure? The equilibrium will move in such a way that the pressure increases again. It can do that by producing more molecules. In this case, the position of equilibrium will move towards the left-hand side of the reaction. What happens if there are the same number of molecules on both sides of the equilibrium reaction? In this case, increasing the pressure has no effect whatsoever on the position of the equilibrium. Because you have the same numbers of molecules on both sides, the equilibrium can't move in any way that will reduce the pressure again. Using Le Chatelier's principle with a change of temperature. For this, you need to know whether heat is given out or absorbed during the reaction. Assume that our forward reaction is exothermic or the heat is released. This shows that 250 kilojoules is evolved, hence negative sign, when 1 mole of A reacts completely with 2 moles of B. For reversible reactions, the value is always given as if the reaction was one way in the forward direction. The back reaction, the conversion of C and D into A and B, would be endothermic by exactly the same amount. What would happen if you change the conditions by increasing the temperature? According to Le Chatelier, the position of equilibrium will move in such a way as to counteract the change. That means that the position of equilibrium will move so that the temperature is reduced again. Suppose the system is in equilibrium at 300 degrees Celsius and you can increase the temperature to 500 degrees Celsius. How can the reaction counteract the change you have made? How can it cool itself down again? To cool down, it needs to absorb the extra heat that you have just put in. In the case we are looking at, the back reaction absorbs heat. The position of equilibrium therefore moves to the left. The new equilibrium mixture contains more A and B and less C and D. If you were aiming to make as much C and D as possible, increasing the temperature on a reversible reaction where the forward reaction is exothermic isn't a good idea. What would happen if you change the conditions by decreasing the temperature? The equilibrium will move in such a way that the temperature increases again. Suppose the system is in equilibrium at 500 degrees Celsius and you reduce the temperature to 400 degrees Celsius. The reaction will tend to heat itself up again to return to the original temperature. It can do that by favoring the exothermic reaction. The position of equilibrium will move to the right. More A and B are converted into C and D at the lower temperature. To summarize all this, increasing the temperature of a system in dynamic equilibrium favors the endothermic reaction. The system counteracts the change you have made by absorbing the extra heat. Decreasing the temperature of a system in dynamic equilibrium favors the exothermic reaction. The system counteracts the change you have made by producing more heat.